Aqueous NaBH4 reduces aldehydes, but not alkenes. Show the first step of the mechanism between NaBH4 and 2-methyl-butanal. Right, so 1, 2, 3, 4. There's my aldehyde, and then 2. So this is carbon 1, that's going to be carbon 2. So I've got that on there. Okay, so first step of the mechanism, I need to include 2 curly arrows. All right, so let's start with that bit first. So CH3, CH2, C, CH3, H, and then this is where the mechanism is going to occur. Now, NaBH4 is a source of H- ions, so there's my lone pair on there. Always a good idea to put dipoles on so that you can see what's attracting what. So the hydrogen is negatively charged, the carbon is positively charged. So there's our first curly arrow there. So a bond has got to break. It's got to be the weakest one, which is going to be the pi bond between the carbon and the oxygen. And because the oxygen is more electronegative, it's going to pull those pairs of electrons towards itself. Okay, so there's the first part done. The next part is I need to explain why it will reduce butanal, 2-methyl-butanal, but it will not reduce but-1-ene. So this is where you kind of need to know your mechanism. So let's just have a look at what happens in an alkene. So when an alkene reacts, if I just use HCl as our starting point, just to kind of explain this, this is D minus, this is D plus. Now remember the carbon-carbon double bond is electron rich, okay? So it will attract to a D plus hydrogen, whereas if you had a H minus here, so if you had a H minus here, this is going to be repelled from the electron-rich area here. Okay, so let's first of all state what is happening here. So the H minus is attracted to the D plus carbon in 2-methyl-butanal. Need to make sure I name the molecule, otherwise I could be talking about either of them. So the H minus will be repelled from a carbon-carbon double bond because the carbon-carbon double bond is electron rich. So marks for that one, so 5 marks, so 1 for each of these curly arrows, 1 for stating that, 1 for talking about repelling because it is electron rich. Part B, a student attempted to reduce a sample of 2-methyl-butanal, so that would make an alcohol, but added insufficient NaBH4. The student confirmed that the reduction was incomplete, so if it's incomplete, I'm going to have some of this left over by using a chemical test. So how can I prove that it's not complete? I need to test for an aldehyde. So the reagent here is going to be Tollens reagent, and the observation will be a silver mirror or silver precipitate. You could use a failing solution, which would go from blue to red precipitate as an alternative.